Alright. Hello everybody, welcome to the stream. Alright, what are we working on today? So we have like one major thing to figure out, and that is how are constructors of types going to work? Like, how are we going to create new types? Now, outside of that, another problem I have is, okay, so we have the type spec system. We have type specs. So if we look at example scripts, you can see we can create the must be number constraint from the value namespace slash object. I'm using the object as a namespace, basically, but it is an object that I'm treating as a namespace. This is basically value must be number. Now we get that constraint. And what we're passing into here is a specification. And the thing about this specification is it's taking up the spot that would usually be taken by a type in other languages. And a lot of times types have members. So in other languages, you would have the ability to just directly pass in a type here, and then it would magically work because it's, you know, type checking just magically works. Like, it just is syntax. You put in the, like, path to a type there, and you have a type. But in my system, everything's a function. So these types are basically assertions. Now, there might be a case to be made that maybe we shouldn't have it just be a constraint is a function. Maybe we need to have constraints be able to be a number of different things. Maybe constraint actually needs to be anything that implements into constraint or something like that, or is into constraint compatible. Because if we think about all the different things, like when we create a type, generally that would be, well, in the case of an object, it's just like we create an object here just fine. So we don't need to worry about constructing objects. I'm mostly worried about constructing enums, now that I think about it. So what I could do instead, because my main problem that I'm trying to like figure out here is how do I construct enums? And I know I didn't explicitly state that, but that's kind of like where my head is at right now. Hello. So when we build a structure, we can just do curly braces, members, and then that is how we define structures. I've had stream elements for a while. That's how I'm doing like the chat overlay. I don't use it for like pop-up notifications and whatnot, but probably should. Usually the bot beats everybody else. Though it is interesting. Sometimes it shows up, sometimes it doesn't. Oh, there's the Discord ping. Well, yeah. So we have the struct constructor, but if we want to create a specific type, then we want to create a specific type, then we need to pass in well, it's a structure thing, right? So what if... But is it just a constructor thing? Well, I guess it would be validated later on. What are your ultimate thoughts on the Tarrasque? I think it would be fun. I don't really have super in-depth thoughts, because, again, I'm not a dungeon master, I don't really have the context. I've actually struggled a lot with, like, role-playing games, and games like League and MMOs, where it's like, there's a ton of, like, small numbers, and those numbers are, like, supposed to mean things. Now, the Tarrasque has big numbers, yes. But a lot of times I struggle with the like significance of statistics. I'm just kind of like, ah, yes, there's numbers there. What do the numbers mean? I guess in League that's just kind of like you need to get used to like all the different ways damage can be done, and D&D is just like, all the numbers are small, so the numbers are actually big. Unless it's a Tarrasque, in which case it's gonna one-shot you. The people who derive feelings from math. Now, I derive some feelings from math. Like when my code works first try, that's technically a derivative of math. But it's also green, usually, in the compiler output, in the console output. And I like the color green, so green makes me happy. The derivative, which is technically also a math thing. So what I'm thinking right now, for if we wanted to create a specific structure, we should probably just put the type label right there. Like that. And then this type label validates the structure. But here's the thing. I'm like slightly second guessing the constraint system because it feels a little bit too open-ended, and a little bit like I could just be putting assertions in the function itself, and they are a bit like wordy in their final stage. So like, could also do like where D is the constraint. Like, I'm basically doing type constraints here. Like that. Because I basically do want to do like trait style constraints. And then with type labels, I guess I could just use a type signifier to specify, like, hey, throw a struct sig in here and verify that all the values are what we expect them to be. That would be the easiest thing, and then for enums, we would just enum signature, and then either just call the enum signature or construct it. But I'm not sure how I like that idea, because now we're implicitly treating enums as a function, when enum is not a function. And that's where you could come up with something like a new syntax, like new, and then there's the enum sig, and then it's like, ah, yes. This is very distinctly different syntax. I hate new keyword syntax, though. Like, I very much don't like new. Because I have to, like, there's like a space there, and I have to be like, okay, I want to create a thing of this type. But sometimes I use new, sometimes I don't. And I don't like typing new in front of every single type I create. Now, I could put new as a member on the signature, but the thing is, the signature itself is can be an enum instead of just an object. So it doesn't make sense for it to have members, plus then like the type sig is now like an interface instead of a specific kind of type, because now, it now can have random like new members and stuff. Now I'm not a fan of that either. So like the idea of enum sig and then an enum variant. Oh, that was the thing about enums I was forgetting, right. Enums have variants. Maybe I just always use a struct signature? That's the thing. How do I specify a certain enum variant when the way type signatures work? The way type signatures work is as a giant enum. Or what I could do, the thing that I could do is, instead of these things here being signatures, this could also potentially solve the infinite recursion system I had before, but cleanly, is have type definitions be different, like type objects. So if we create a type object, sorry, I'm smiling because I'm having a side conversation with some friends about the... So, they're on Twitch. So I multi-stream to Twitch and YouTube. YouTube is usually where I have the highest viewership. But I was like looking at like different Twitch things and whatnot. And on Twitch, the software and game development category, which is what I stream under, has 1K concurrent viewers right now. You know, weeknight, kind of later. Not a ton of people. The VR chat category has 5K people watching it right now. Now, as you can probably tell, I am currently in VR chat to, you know, some extent. So, what if, instead of being a software and game developer, I was a VR chat streamer? There's a bigger total addressable market, theoretically. But here's the thing: if you go to the VR chat category on Twitch, you'll notice a consistent theme. For all of the top streams. And you know, people are free to watch whatever they want to watch. I'm just saying, like... But yeah, so VR chat is currently, oh, it's up to 6K now. And then software and game development, the category, it's only like 1K. So maybe I would have more discoverability over there. Now Twitch doesn't have any discoverability whatsoever, so why do I care about Twitch when YouTube is the only stream that does well? I don't know, it would just be kind of funny to be a VR chat streamer and like code. Use that as an excuse. But anyway, they were saying that I should run 2 simultaneous streams to Twitch and have one be good variant and one be the evil variant. One of the name suggestions was Gyre Jizz. I'm like, nah. It's gotta be Wire-Riz is the evil variant. where you know you fully embrace the VR chat audience and appeal to them. But no, we're gonna stick to just coding. I'm gonna just code for now. Now there's another potential solution here to some of my problems. It might be callable objects. It might be one of the things I need. The VM should have a call strategy. I've been thinking about this for a bit. How do I do closures with captured variables? And how do I do... Yeah, it's mostly how do I do closures with captured variables, but also do potentially closures with mutable state in the case of something like a loop iterator. But now that I'm thinking about it, I could do closures that capture variables. I could do that without capturing state, without turning it into an object. Like, I could just make that part of the runtime, or would I make it part of the runtime or parser? It would have to be part of the runtime, I guess. Or part of both. Do I want to do the C style where it's like grab a label from the outer scope explicitly, or do I want it to be implicit? I think implicit makes the most sense. Okay, I'm getting completely sidetracked on closures with captured outer variables. On an object, instead of a function, it can implicitly call one of the members of that function as if said function instead possibly passing in a self value. I only hesitate because I'm intentionally trying to keep this the language as simple as possible right now, but I'm also hesitating because I want the language to look nice instead of being... See, it's already kind of getting out of control. Like, where... Like, objectively, function constraints are too verbose right now. Like, ideally, this would literally just be number here, plus whatever constraints you want. Like, let's just say you add in a not zero constraint there. And it's theoretically that easy. I'm tempted to do this as a where clause instead. I'm also tempted to steal the... I'm going super like ADHD here. Completely off track. Tempted to steal the Rust syntax for this just because it's smaller. I could also steal the JavaScript syntax. JavaScript and C#. Which, if I'm thinking about my target audience, this is what all of them are going to be used to. Is something like this. With a possible return value here. No, that looks terrible. I guess I technically still do have the arrow syntax for setting return values. or more specifically return constraints. Okay, I really do want to be able to just put in type labels as constraints. So I may move to constraints being you having a number of different options for what a constraint can be. Or maybe? Lots of indecision. Okay, let me actually write down all the different things I'm considering. How to or the syntax of enum and struct construction. Creation, the strongly typed version, and I would prefer for struct. I prefer label.variant for enums to have this syntax exactly. Syntax of constraining. The types of function arguments. Function param label, just directly the label of the thing. I'm having an idea that may work with how the way things already work. Let me type out the rest of the things I'm thinking about. We want to avoid implicit rules like magic struct members. An example would be a constructor. Would be a constructor field. In the add field, the struct work with operators. And ideally, the operators work is by register. Dang it, do I have to do magic struct fields? I don't like that idea. I don't like that idea at all. Yeah. Not sure that's the way. Oh, but see, here's the thing. Is values don't currently store any type information, so the only information I have about a value, like a value's type, is like the structure of the type itself. Do we want to have explicit type? Do we want to have type metadata? As a not directly represented in a value, but instead stored and mutated separately. See, this is the real question. Where it's not directly on an object, but through some intrinsic function calls, it can be retrieved. But not... Do I want types to be directly modifiable? Like, do I want to allow compiler metaprogramming to be able to directly say, hey, this thing now has these traits? I don't think I want... I don't think I want compiler metaprogramming to be able to do that. Makes me think don't want compiler metaprogramming to be able to break the contracts set up by I don't want compiler metaprogramming to be able to break contracts set up by traits type info. Currently, the way we solve this is just by having type info be emergent from the structure of data. And this is how, like, TypeScript does it, for instance. You just enforce that the data will be in a certain structure, but you don't necessarily enforce the values. Like, yes, you can enforce, like, that a value is not null, but that's like a... null is a type, or undefined is also a type, rather than the actual value of the thing. Another concern I have right now is that constraint functions are slow, or will be slow. Function constraints, as currently implemented, will be slow. If properly implemented, the current system would check every single value and member of every value passed as an argument to every function. Meaning that for every single function call, we iterate all data passed into that function. This is only compiler side, but we want good iteration times. So we don't want really bad performance. Because ideally what you would be able to do is run the script every single frame. Like, ideally. Also, ideally, the compiler is coded in the compiler functions are coded in the same way as runtime functions. Even if the compiler VM is dynamically typed, this means that it at least needs to look like it's strongly typed. This is making me think we do need to we need to add a type system to the compiler is basically what this is making me think. The compiler will still be fully interpreted, so it's still going to be easy to code. Yeah, we might need to do a type system for the compiler, and then compiler no longer dynamically typed. Compiler is VM, but compiler no longer dynamically typed. It makes me think about things like well, you eventually know all of the types of things. And I think I need to start... Wait a second. I like that idea. What if... instead of functions... what if values were secretly a tuple of two things? So we have a value, and then type info about this type. And then whenever we create a value, we could use type info to infer what interface we can use with it. So in the case of numbers, that isn't really anything. Well, yeah. In the case of structures, it's like... here's what my values are. Here's what they can be. I guess that's more of like a interface. Just thinking, how do we... what is stored in this type info? Obviously, it's... wait... I just realized something. What are constraints? When you're putting... when I say constraints, is because I want the compiler to be able to statically verify the values of runtime data. So without knowing everything about the value that is being passed in, we know for certain, we know for sure, certain things about that data. Now, if the compiler is a completely dynamically typed system, then the type also becomes part of the value. So, if I redefine constraints to be... we may constrain the allowed value data a value may contain. This is essentially a compile time assertion that data held by a compiler value is... this is not an assertion. An assertion is the wrong way to think about it. A compiler... an assertion, a constraint, a value constraint is a way for us to define in a function body, here's everything we know about the data being passed as this argument. Now, within the function, we should statically verify that we only do things in the function that we know has been passed in. So for instance, instead of doing the thing I was doing before, compiler side, where if I didn't define constraints here, I could call add. But add does have the constraints of number. It does have these constraints. What I should do is even compiler side, where I'm like, hey, this value could be anything. This add says, I am only equipped to handle if those two values are a number. Now, I currently would get a compile time assertion when it tries to run the function. Like, whenever this function is eventually called down here, this is where the error would be triggered. We want this error to be triggered when we're defining the function, because the error is here, not down here. And because this is a runtime VM, we could handle this like at the time the function gets called. You know, do a call stack and go like, when called here, with a non-number value being passed into here, and then here. And then it would just like, it would after the fact tell you while you're at it like here, like, hey, this isn't a valid value, do better. But here's the thing. We don't want to wait until we call this to know that it's broken. We want to be able to work on it here and then know that it's broken, know if it's broken or not as we actually like define this. Now, I do kind of like the C++ paradigm of templates, where you figure out if a template is broken when you first try to use it. Like, that's... I still kind of miss that, even when I'm working with a type system as good as Rust. But for what I'm thinking about now, it makes a lot of sense to just have constraints be part of the actual values, and that will help stuff like context-dependent code suggestions. But anyway, what I'm getting at is we define a type, and this type constraint is a value, like the constraint itself is a value, and the value contains a specification and all of that. But the value could also contain things like traits that a value will hold, or we can add traits into it, but number could be a collection of... Ooh. Number could be a collection of value traits. I just wonder, do I... I'm just trying to decide, do I add member functions in? And I know I'm overthinking this. So it's like a security checkpoint to make sure your data is compatible before the function is called. Exactly. But it's not even before it's called, it's like, it's more like, let's say there's a pamphlet given to TSA of like, here's who you let through, like here's the things you check for. And then TSA set up the lines in such a way that only certain things that get... I don't know, that's still a runtime check. How would you verify that something works before actually sending it off? It's like if you run a simulation with everything you know about a rocket launch before launching the rocket, and if the simulation works, you know 100% for sure that the rocket launch will work when it actually launches, if all the data you passed in was correct. That might be a better metaphor, is it's like running a mini simulation ahead of time, so you don't have to do simulations after the fact. But anyway, all that I'm getting at is it makes a lot of sense for constraints not to be functions, but to explicitly be not compile time assertions. Since the compiler VM is technically dynamically typed, but we want to write compiler functions with exactly the same format as we want to write compiler functions with exactly the same format as runtime functions. So it must act as a statically. So at least syntactically we must treat it as static dynamically typed, even if we can. And I do think there will be ways to express dynamic typing, but explicitly force people to handle the result of it being dynamically typed instead of just letting it error, I guess. So in the case of a compiler macro, you could put in an any constraint, like any value type. And put explicitly that constraint in. So this is explicitly, we're allowing any. But now, because we're treating this as statically typed, like for our control flow and validation, we need to know what types are. Right now, whatever I'm doing here, if I did this, did DC like that, this Brane, work with me here. Right, this would throw an error at the definition stage, not at when it's called. Right now it would throw an error when it's called, when it gets to the add function. But we wanted to throw an error when it gets to this actual definition. Function cannot be defined. Brane, no one. Work. Brane, fight. This is fun, Brane. This is fun. You will see it as fun. But we can get around the any type being anything by just treating it as an enum of any compiler value. So we could do, eventually, not right now, this is like at some point, match on D, and then have, we could add in conditions for if D is a number, for instance, so you can kind of see what I'm saying here of we match when these constraints are true, when the value is these things. We take this branch. Makes me think of a not filter for types. If not number, please give error. Similar, yeah. It's like the Rust trait system if the type was also a trait. So this entire function would be like a generic like DC, and then you put D and C into the types, and then did like a where D equals any and C equals number. So it's like C# or Rust style generics if the type was also a generic. Part of the generics, I guess. This actually might be the way we do, like, match statements. I might have accidentally stumbled upon this syntax, because I really like this. Because then we can do a match statement where if we have the constraint not 1, suddenly we can take this branch of execution if our number value is definitely not equal to 1. Because if we're able to constrain all the possible values that a value could be, then we're able to basically pipe data through different channels. Because I was not planning to. I was planning on not having if statements and only using match statements, but I was planning on having stuff like compare. Like compare for equality or equals. I guess equals can still be a function, but constraints could be used in a match statement as well. Like, this is specifically a number, or this is specifically my enum dot my variant. And this is explicitly like, take this branch path if D is this variant. I guess that's just a regular match statement, isn't it? But I don't like the syntax of match statements, how everything's like super nested and stuff. I guess it is kind of a match statement, but with the values that things could possibly be also passed in. We're not going to do this. We're not going to have like inline destructuring or anything at this point, so we can keep it really simple. Maybe this needs to be called branch instead of match. Match is a single character shorter. We're keeping match. It's all back to the match statements. Okay, so what all of this means is that constraints, there can't be user-defined constraints. All constraints need to be a compiler-defined syntax for everything. or at least compiler define it. Constraints are a compiler defined data structure. So you may be able to construct a constraint through metaprogramming. Like, I still want what you pass in here to be an actual value. Or do I? Because for passing... I guess that goes back to how we define... How do we define types in this new... Types are another constraint on a value. Types are also a trait. Not directly checked. Maybe types aren't a new data structure. Maybe types are a combination of pre-existing constraints. So, in the case of structures, a structure data type would a structure constraint or a structure definition could be a combination of you have this type and you have this type and you have this type, but also like the compiler defined constraint could include the struct must have this member and the struct must have this member, and not have it as necessarily a nested data type. Well, that's still the spec data type that I came up with. Maybe we just need to expand spec to also contain values, and then just specs are the only constraint. So what if the spec value of data should be describable by variance of this enum? This is now all constraints are this enum. So I no longer have to worry about scoping this. And maybe options needs to be an object. Instead of an array. No, no. So number now also needs to contain a number of possible data. Error we don't need to worry about at all. This is just, it's an error. At least for now. Unless we want to like, oh, this needs to be a specific error from a specific place. Rings? Strings should really just be an array data type with numbers, and those numbers being 32-bit wide ASCII characters. Oh. Keep it simple. Now that I have the API, like compiler value API, that will make transferring between compiler value arrays and compiler strings a lot easier. Maybe I should have array be enum variants, with each one of the enum variants being different values, because at the moment Alright, I'm gonna dip for 5 minutes and then be back. Think about it. Yeah. So I think, just for my own sanity, I am going to have to define a thing, a concept called a type. And the reason for that is because my brain is too type coded. Like, I need types to function. No, like I'm just statically typed. Cannot operate dynamically. There needs to be a thing called a type. I've been like, no, there's types and traits and all these different things. No, we need types. Types of data. So it's not constraints for types. I'm gonna put it up here. Types. Fine, heading to. Types. Types are an array of traits. These traits constrain the possible values we can say these traits can, or each trait is a description of a small part of a each trait is a description of a small part of a value. And this value can be constrained all the way down until a value is upgraded to till a value can only be one possible value. All possible values and ranges of values can be defined as traits, can be described by traits. Trait aliases can be defined at runtime. At runtime by constructing types may be constructed at runtime by at compile time by combining multiple trait definitions into a type. These definitions are a compile time value and can be modified through scripting. However, no new base traits may be created at runtime. Though it might look like it because of trait generator functions. Every value stores its traits. Every value also stores its. Now see, here's the thing. If traits are purely just a One second. So when we evaluate a function, now this is turning our function value here okay. So we could do function valuation here in the evaluate function. Yeah, we could do evaluation here. Do the actual type checking there before actually running it. Which means instead of getting weird... Oh. I don't know if every value needs to store its traits. I'm thinking about it. The compiler theoretically executes entirely in the trait system, but you have functions that can export traits. It's not explicitly what I've been building, but that's a specific, that's how metaprogramming works in other languages. Is you have, like, through the type system, you can express logic in the type system. Usually not very well, because they never cooked it into the language as a default, as like an originally intended feature of the language, like we're trying to do here. But do values need to store their traits? Do values need to store their traits? Or do we just need to validate when evaluating a function originally? Return values from functions need traits. Return values from functions need traits. Do functions... I don't want to have to explicitly give the output of functions. But here's the thing, I might be basically forced to. Here's the thing, if a type you can make it easy and say every value also stores its traits. Compiler value also stores its traits. Traits may not be directly modified except through operations. On data. Except through operations on the data. As their only a description. But they can be influenced and matched on. Essentially, constraints are, at some point we're going to have a match statement syntax that contains all possible values. we will have a match syntax that contains all possible values. Truly, traits will be used to define match statement. I got it. Okay, I figured out one thing that I was background processing in my mind, which is okay, if one function returns two different value types and we're implicitly determining the return value of the function, then okay, in the case of a function that can return either a number or an object, then the return type of that function needs to represent that that type can be a number or an object. And I was thinking okay, but types, if we're specifically return type must be this specific type, then it would error because those are two different types being returned. But if parameter and return traits are simply this value must be described by these traits, then if this value must be described by these traits, then it doesn't care about any extra traits that are returned. It only cares about the explicitly defined ones when type checking for the user. Basically, those are user-defined type checking, but we can have implicitly defined or there can be implicit trait. There can be implicit. I'm just thinking about compiler optimizations right now. If a value that we know to be 0 is passed into a compiler function which has a match statement which matches on 0. But wait a second. That's just the same as the compiler just straight up executing. That's just the same as the compiler straight up executing. Which means through this system, through this system, the execution of the compiler will implicitly optimize stuff. Because if I'm thinking about this, let's take number for instance. Number can have the trait integer, number can have range. Like what range can this number be in? We can have the bit width of the number, so this could be like a 8-bit, 16-bit, 32-bit, 64-bit, maybe 128-bit number, and this can also be like explicitly a float number. So with the combination of these traits passed into an addition function could emit a value that is a runtime addition operation. Oh, no, stop. I don't want to use the AI. This is kind of making me think that I could design this entire system in another language, because the runtime stuff that's emitted, and this is actually a thought I've had before, I just don't like the idea of giving up a custom syntax to use another language. But you could technically use another language and have the execution of that language emit BraneScript modules, which means you could like have a JavaScript or Lua program that emits BraneScript modules. I don't really like that idea because it doesn't, like, I wouldn't be able to do custom match statements, for instance, and like fun syntax and stuff. So we're gonna stick with custom syntax, but the idea is that, or the thought is that, like, you could use any language to write the runtime and kind of do what I'm doing here. But I guess that goes for any compiler. You can write any compiler in any language, or grammar doesn't matter. It's another way of saying grammar doesn't matter when it comes to the actual runtime. Where was I going with all of that? Right. Functions must declare or rather traits. Functions define what operations they can execute depending on the traits of its arguments. And vice versa. Functions can only execute operations that are allowed by the traits. The parameters. and vice versa. Functions can only execute operations that are allowed by the traits of can only execute operations that are allowed by the traits of its parameters. This is implemented as since all possible behavior is built on top of intrinsic since all possible behavior is built on top of intrinsic functions, and those functions will have traits as arguments. Okay. I figured out when trait checking occurs. Trait checking in functions occurs when the function is defined as a value. So if a function, we attempt to define a function So if we attempt to define a function a function is defined as a value. So if we attempt to define a function with an invalid structure, an error will be emitted instead. So that means in here, instead of when we call the function, it's when we define the function. So my add would become an error value if function was not defined correctly. right now I'm just thinking about a way to collect all the error values in a function, because errors are values. They're not just straight up emitted, they are values. Because I don't want execution of the compiler to stop because we hit one singular error. I'd like to get, like, if we define two functions right next to each other but then don't call them for a bit, then I want to get errors for both of them. So I was just thinking about, like, the squirreling on error propagation. So right now, errors kind of suck, and errors are also nested inside other errors. So if I call add, and one of its arguments are an error, I don't get an error that my add had an error. I get an error that struct add wasn't able to be called because the input structure wasn't a number. Oh, but also one of the values of this structure was an error because that didn't execute correctly, and that's like very unreadable. So we need to come up with a way to propagate errors properly. Hopefully the errors themselves don't have errors. I don't think the errors themselves will have errors, but I do think, one, I want to be able to use errors as values. I want, like, because I can imagine in metaprogramming, go try to define this function, try to call this thing, and then as a fallback, try this other thing. Now, that's like a vague idea. Theoretically, the trait system makes it impossible to... The trait system might make it impossible to make errors like that. Because the idea is that it's just all correct. Okay, so I might not need to propagate errors. What I might need to do is just emit errors to the console when I get them. Pass them as values, because it still makes sense to have them as, like, hey, what was the result of the last function? It was an error. Okay, now this also errors. Or not. I don't really want any errors because other things are errors. I just want... Actually, no, that... For nested functions, it makes sense. Anyway, we just need to make sure that errors can be displayed in a clean way in the order that they occurred. Like, the most nested error is displayed first, instead of being the hardest to read. Because right now, the most nested error, which is the first error that happened, basically we need to print all leaf errors. Like, if we had a tree of errors we constructed from every single possible value, leaf errors would be the ones we want to... Actually, I like this. I'm going to write it down. Error handling. I cannot spell. Error handling. Errors are stored as values, are unrecoverable. Compile time. Error handling. There are no runtime errors in say. Here, can I change this to a quote? Yeah. There are no runtime errors in bossing say. Because of the trait system, we are able to statically account for every possible value that might result in a runtime error. Thus, we'll never get them. I'm gonna throw a thumbs up in there. Can I get a new line, please? Thank you. But we do still have to handle compiler errors. Dynamically, statically typed language sounds like cold hot. Yes, it does. Basically, imagine if your compiler was a dynamically typed virtual machine that emitted statically typed binaries. That's essentially what we're trying to do. Now, I'm currently course correcting to the virtual machine of the compiler is dynamically typed, but the actual syntax is statically typed. Or at least partially typed? I don't know. Described with traits. Imagine if you were using either the Rust or C# generic systems, where you can say these types need to either implement these traits or interfaces, or in the case of Rust, also lifetimes. But imagine that was just every single value, and everything down to the storage size and bit size of a value were defined using those traits. So when you call a function, the function will always work as long as you only touch functionality that requires a value to be the storage of that value and value of that value to be within those parameters. So in my system, I have traits similar to Rust, but they're more expansive than Rust because traits can also define the possible ranges of a integer, for instance. So you could have an integer that's not 0, for instance. That's important for division. In which case that would be a value that has the traits number, integer, and not 0. So a value being a number itself is a trait, because the compiler starts with the assumption that this value that's being passed in could be anything. And if you're writing a compile side function, like a function ran at compile time, because my system makes no distinction between a function ran in the compiler and a function ran at runtime will look syntactically exactly the same. And have access to good data structures and stuff. But you're able to constrain those values down to only the values that will result in a function executing correctly. So you run dynamic typed languages in VM, but later want to also emit a good static binary. So when you run the compiler VM, it's pseudo running your code. So let's say this add operation here, let's say this add function gets called at compile time. If it's passed 2 compiler values, it just emits another constant compiler value. So if it's constant 1 plus constant 2, it returns constant 3. But if one of those values is a runtime value, instead it returns a runtime operation object, I guess. So then the result of your compiler, script running is a set of runtime operations to execute. So it runs the script you see here, but it doesn't actually execute a runtime program. It just constructs a binary that can execute a runtime program. That makes sense, but we still do have to handle compiler errors, which are stored as variants of compiler values. Okay. If we imagine the program as a tree of operations, if we imagine the program as a tree of operations and errors as leaf nodes connected together, I failed function calls, then the tree of operations, then when evaluating this tree, some leaf nodes would evaluating and reducing this tree, then we would start seeing error leaf, eventually a function will return a function might function branch producing this tree, a function or a node that binds its leaves then when evaluating and reducing this tree, a function, or in other words, a node that combines its leaves, may return an error if multiple leaves of a single node are reduced to errors. We don't want to reduce to a single error. Instead, we lose errors. So we combine errors into a tree. As a So we combine error leaves as a list. If a function is evaluated and combines multiple errors, and its args contain multiple errors, or tree. If a function is evaluated and its args contain multiple errors, we don't care about the function, about reporting that the function failed, since the failure was from further up the tree. I just realized the trait system causing there to be no errors technically also applies to the compiler if we're using the trait system compiler side as well. Then a pass to check all of the traits is really all we need. Let's see, do I do all my things in Rust? No, I kind of jump all over the place, to be honest. I do a fair amount of C# for my main job. I use TypeScript when absolutely necessary. It's actually been a decent amount over the last couple months. Let's see, do I do anything else? I occasionally write a utility script in Python, but I just generally use the best tool for the job. And for writing languages, Rust is definitely a very good tool for the job. Okay, so I was thinking too dynamically typed about this. No, our compiler has a dynamically typed runtime, but the syntax is statically typed. The syntax of the compiler is statically typed. This is good until it takes 1 minute to compile, and for Rust Analyzer to start 15 seconds. I haven't gotten to that point in any of my projects yet, and I've gotten, like, decently large projects. I mean, do you mean from a fresh start, or... Because, like, from a fresh start, yeah, like, nice stuff can take a hot minute to compile if I do it from fresh start, but if I have, like, a fair amount of stuff cached already, like, if it's my second compile, then it runs fine. Execution is fine if it's a second project, or second compile. So I essentially need to re-go over this spec. Yeah, we need to re-go over this spec and remake it with the knowledge that constraints. Yeah, so this constraints is not talking about the constraints I talk about later. Pattern matching system will have direct one-to-one parity with grammar concepts and the trait system. I just had an incredibly cursed idea. Since the pattern matching system has direct one-to-one parity, or will have direct one-to-one parity with the trait system, instead of doing instead of doing trait constraints like this, you could just have it be you could just have it be pattern matching. You just pattern match arguments into the function. Wait, does that mean that this constraint syntax is actually a pattern match? I could define it that way, and then like in our match statements, we could start out with our MVP grammar, defining them this way, and also setting labels to be that way, and also destructuring. Like destructuring, this is eventually going to be a pattern match as well, right? Just an unconditional pattern match. So, this is a variant of a pattern match. I see no reason that could possibly fail. The only failure would be it would be potentially hard to read. You know, but potentially. Maybe, kind of. It would maybe work. Means technically this match statement is also an enumda structure. We could make match statements pattern match statements. Hello. You arrived just as I was realizing that if you think too deeply about any programming concept, all other programming concepts start losing meaning. The entire program can just be one giant match statement. Or pattern match statement, specifically. If you're also taking into account enum values. Then again, match statements are... Yeah. We'll back away from that slightly. Tautology. What is tautology? That looks like a fun word. One-to-one? This is true. Everything in programming is a transform. Yeah, this means shared values can also be part of a match statement. This probably means, like, when you eventually add the, like, shared as like a reference syntax. In fact, I think Rust lets you pattern match in arguments, because I've seen that in some things, and it's incredibly cursed. Oh, actually, yeah, I use it all the time. Whenever I'm mapping it and I destructure a tuple in the arguments of a closure. Who made this Brane script blank? Me. We are currently working on it right now. This is not the final form of the grammar. This match statement currently is... This is my musings, as I'm trying to decide what direction I want to take things in. Because we have a lot of stuff working. Here, let me actually reconstruct this to a working version of itself. I think this should work. Oop, I am not in a scoped terminal. Let me reopen real fast. Wait, 32. Ah! We'll just... change directory then. So, cargo, run, example, scripts, test.b script. And there we go. So this is the current working version, which returns 6. And this is a compiler constant 6. This isn't like a binary. So the idea behind this language is that the language itself is all... I mean, a better way to explain it might be the entire language is a compiler macro, like a compile time function. So a script that gets run at compile time, but the intended output of this compile time script is a runtime, like a compiled binary, basically. Running one language to get not another language, but a runnable version of the language. So you run it, and then you actually run it. Right now I'm just trying to figure out how I want to structure the data on the compiler side to best match the way stuff works on the runtime side, and I got slightly distracted by how I'm going to do error handling. What I realized is that all of the validation and error handling of this script running happens, all the validation happens at the trait level, and then we reduce it. Basically just call one reduce after that point. Like if all the traits match up, it will compile. Yeah. So need to finish defining the new trait system and where exactly it's stored and where exactly it's evaluated. How I want to handle that in the type system before setting out on another refactor. Do you know about dependent types? Let me do a quick Google search on what this specific term means. Types. Type whose definition depends on a value. So is this kind of like what was I gonna say? Like implicit type checking? Oh, hi, Sim. An int of value 3. I'm not sure exactly what you're referring to, but this is probably a similar concept. Well, see, we needed to decide how we want it to function first before we can actually get it to function. It's checked statically, but okay. Is that just a... It looks like a grammar of defining things, but that might be similar to what we're doing here. But I'm not... Without like a little bit more information on how it works like internally, I can't really say. Cannot be proven statically. It warns you that you need a runtime check. Interesting. Actually, that is kind of what I'm doing here. Where, yeah, like the division function, for instance, won't allow integers with a value of 0 to be passed in, but that's going to be a statically checked thing. So it won't explicitly like make you do a runtime check of the value, but it will be like, hey, the value of this integer can be 0. That's not allowed. So then you do need to like do some form of operation to make sure that the integer value won't be 0. Has a person inside a condition branch. Yeah, that is very similar to what we're doing. Or might even be what we're doing, but I just don't know I don't know the terms for things. I kind of just like listen to the occasional language talk, or like a fair number of language talks. But I do kind of wing a lot of this. So I know things, but I don't know what those things are called. Because I wasn't paying attention to the names, just the concepts. Phantom data in Rust. Yes. And I'm not super a fan of whenever I have to use it, and usually when I have to use phantom data, it means I'm going to completely refactor whatever I'm doing in around 30 minutes. What is the goal of your language? The goal of this language is to be used in a VR-specific game engine. Specifically, as a sandbox, dynamically loadable language. There's a lot of goals for this language. It has about 5 years of scope creep right now. And this is the third attempt at writing it. We're about like a week in to the third version of writing it. And I'm feeling very good about this time because I actually have a living spec document as opposed to just winging the entire thing. Not that I haven't written spec documents for other ones, but this one I started out and like, I'm really trying to create the simplest version of it possible before adding in any form of syntax sugar, for instance. Because before I got like super focused on like, okay, now I have to write a parser for all of this syntax sugar. And like, I don't need syntax sugar to get a working game engine working. I just need a language that does what I want it to. Or not even a language, I need the runtime underneath the language to work. So the actual way to interact with that runtime, the language, can be as bare bones as possible to start out, as long as it can evolve into something more usable later. But yeah, eventually I'm gonna have to make a like pretty long video or series of video. Thinking about it, it should be a series of videos on all the different goals of the language. Because I released a 40-minute video like half a year ago, and a lot of people liked it, a lot of people watched it, but the consistent feedback I got from literally everybody I know is either they had to watch it in portions or didn't get through the entire thing. Like, they liked it, but they didn't watch the entire thing in one sitting, ever. Which, like, I'm the sort of person where I will just put a video on in the background and listen to it, even if it's, like, multiple hours long. Like, interviews and whatnot. So it was, like, a little bit weird hearing, like, literally everybody say that, like, they weren't able to get through the entire thing. But when I say everybody, I mean, like, 9 out of 10 people. Like, I know some people who did get through the entire thing, but the vast majority of them did not. So when I do make a video about this, I should split it into 15 or 20-minute portions, which will be very difficult for me, because there's like 2 hours of rambling about this, and that's if I cut out, or if I like very much slim down everything, or all of the goals. I don't think I need callable objects. I'm deleting this. This was me being unsure about the weird constraint system I was going down. Which, thankfully, constraints have only been a 2-day detour. And we're actually designing the system, so we are just getting rid of constraints as a concept. It is now simply just traits. The type definitions. Alright. Thanks for sticking around while you could, though. It is appreciated. Yeah, YouTube chat has a 10-second delay on my stream overlay for some reason. I don't know why. It do what it do. Type definitions. Types. I know the name Haskell, but I'm expecting Liquid Haskell to be a different variant of it, or is this the thing where like there's multiple Haskell compilers? Because I have heard a little bit about that too. Now this is like a functional programming language that I'm writing right now, but I do have gripes with the way functional programming languages are usually implemented, mainly like everything must be in a mutable data structure, and then you have to make a runtime that's able to support immutable data structures, and also mutations or new versions of those immutable data structures. So if I have this old reference to this data structure and this reference to this data structure where I've added this member, oh, now we have to do like the weird tree node system behind the scenes, and like I'm writing a game engine and I am like as OCD about this enough to write a JIT compiled runtime from scratch just so that like I can handle memory very slightly better than Wasm does. But I do like the concept of functional programming of the pure function. I will take that portion. And then I also like the way Rust handles an affine/linear type system. We'll take that. I don't like the way it handles borrowing when applied to a large code base. And like one of the hardest parts for people learning Rust is like lifetimes scare people. Now, they shouldn't. They're really not that difficult, but they do scare people. So in here I have a thing called a shared value, which is basically a borrow, but it's easier conceptually to understand, I think. And we also have... We don't have the concept of a mutable borrow, though. That's just basically going to be a... Mutable borrows is going to be like... how am I going to handle mutable borrows? I can handle that with the type system as well. We can make those like ref types, actually. Or it can be a pointer type. We can do mutable borrows the same way we do shared values, basically. Which is by splitting off two different pieces and then recombining them. Or transforming it into a different data type, passing it in and transforming it to a different data type when it comes back. But at the end of the day, it is a pointer. but I was zoning out thinking about how I'm going to handle pointer types. But if we get everything else working, pointer types are going to be easy to handle in references and passing stuff into the function. I think linear types are a gimmick, and better static analysis tools are good enough so that you don't need them. But that's the thing. Static analysis tools are what they're doing behind the scenes is turning your types into linear types. If they're good enough at their job. So the Rust behind the scenes, Rust is, well, they're affine types. I'm not going to do, not everything is going to be a linear type. Everything is going to be an affine type, though. If you look into Rust, it is an affine type system, and borrows are a way of representing that. And it makes it is a form of static analysis. So I wouldn't say it's a gimmick, but it is something that can be abstracted over. I'm just like, I want the benefits of the analysis static types can bring, but I don't know if I'm capable of writing a static analyzer good enough to give me those results without just directly making the language itself linear typing. So, possible skill issue, but it's a skill issue that can be fixed later and still maintain backwards compatibility. At least the way I see it. You can make something, you can abstract something more, but you can never de-abstract it, is always my my viewpoint on things like that. Like, if you make an easy to use thing and then you try to upscale it to be able to handle more complicated use cases, you're gonna struggle with that. But if you start with it being able to represent everything it needs to do, you can then abstract on top of that, and that's fairly easy. So every no-code, low-code tool eventually fails. And scripting languages are still around. Alright. Syntactically. From an ease of use standpoint, we want to be able to scope functions by types. Variant that has a range. Do you mean the number trait that is range, or a enum variant that is range? I guess if you want, one of my greatest hot takes: integers are enums. Anyways, with that said, what the range trait kind of describes is a number, the value of a number may be anything within this range. So starting out, a number may be any value between -infinity and infinity. But then, if you do a comparison operation on that, like greater than 5, suddenly the range is everywhere between 5 not inclusive or inclusive, depending on if we're working with floating point variables or not. I guess range does have to, if we're working with floating points, range does have to take into account inclusive versus non-inclusive. Or maybe range becomes non-inclusive, and then we have like a might equals. I don't know. Anyways, your new range would be between 5 not inclusive and positive infinity. And then if you did another comparison on it, that would then further reduce the range or not affect the range at all. And if you did a comparison of like integer is more than 5, and then you did value is more than 2, but you had previously done that last comparison, this range integer there would then, you could do like a match statement on it or check that trait, then go, oh wait, this is a constant value now, because we know that the value will never ever be in this range, so we can just constant fold that expression before even hitting anything like LLVM optimization or whatever. And you can also use the range trait to represent if you have multiple ranges, you could use that to represent like not 0. So not 0 could be 2 ranges that are everything but 0. Now, I don't think I'm going to do it that way. Right here I was doing what's the minimum number of things, and technically you could represent every possible value of an integer with an array of ranges. And I guess with an integer specifically. With a float, you have to start thinking about inclusive versus non-inclusive. We probably will have different trait types that are a little bit easier to work with. Yeah, we'll have different traits in there that are easier to work with. Like not 0 or less than, greater than. But range is kind of like the thing that you can represent all of those with. And then with enum variants, the way that I'm currently storing this is an enum variant can be any of these options. Or a value can be any number of any one of these enum variants, is how I represent that. It's like the interval domain. Probably is that. I hate that abstraction. Now the question is, do we keep the value spec enum? Oh, wait a second. No. would still be recursive. Seen the language wolves? I have not. Wrangling untrusted file formats safely. So is this specifically a language just for parsing? And specifically parsing in a safe manner? That is pretty cool. Okay, I have a problem with the... So the value spec enum might become the basis of the new trait system. Because if I just add in extra stuff to be like, what possible values can this number be? Take error out of there because we don't want to allow errors to be a known data type. Function constraints would then be value spec. You're making a compiler in Rust that will compile your language into... It will compile it into an intermediate language, like an IR, that is intended to be loaded by a language runtime. So like a JIT compiling language runtime. And then that's what actually runs the code. So the idea is that the output of this compiler would be the final resulting binary that is also like serializable, storable, send over the network, whatever. And that binary itself can't represent unsandboxable things. And then the runtime is able to just load that up and then execute it immediately without having to do any optimization on it or like validation to see if it's safe or not. Very like WASM-esque in that. A lot of inspiration from the WASM spec in how I handle that, but with some differences to memory to allow us to not have to straight allocate 4 gigabytes of memory or do runtime checks on stuff, because I don't like branching for every single pointer access. Final runtime is not an interpreter. So I currently have, now I might for debugging purposes at some point, but I currently have no plans to actually write an interpreter. It fully JIT compiles the IR. The IR is more of in like a AST form, not AST, the SSA form graph than an actual like bit code. But Yes, the final output is different from x86. The runtime itself would JIT compile it to x86 at runtime, though. Because this is intended to be like a cross-platform runtime loaded scripting language. So it should be able to work on like an ARM device, should be able to work on an x86 device with no knowledge of the end runtime. But if you want to support ARM, you have to create the SSA to binary part. I don't. There are two different backends that I can... Yeah, I do have to write the translation actual backend part. But LLVM has a on-request compilation module, and that's currently what I'm using. I have a written backend that actually works. But then there's also Crane Lift, which is, if I compile this all to a quest and LLVM is too slow, I'm going to write a Crane Lift backend, which they currently use for WASM. This is what they use for the, not WASM time, it's, no, it is WASM time. Yeah, the WASM runtime uses Crane Lift, which is an open source Rust library. And I can just pull that in, JIT compile the result, so this is like one last step, and then I have just a literal function pointer I can call, and it's like an actual native function called the same way, with just as much speed, with the caveat of you don't have like CPU architecture specific optimizations. I do hope to get stuff like a SIMD in there eventually, though. That's a pretty, to my understanding, pretty universal thing. At least at the basic levels. And then if a CPU doesn't support SIMD, then we on the JIT compiling phase we can just emit operations that act like a SIMD operation, and I'm guessing it would still be, you would still get speed improvements from well, actually, for like CPUs trying to look up instructions ahead of time, I don't think it would slow them down to be treating things like SIMD. Even if they don't have SIMD instructions. Okay, so for the type enum, and I do very much keep ADHD jumping around here. No, the SSA is a something I define myself. It would be in runtime, Brane core IR. So this is the form. And then I say SSA because any instruction can refer back to the result of a previous instruction, and that's how the SSA portion of it works. So if you yeah. I guess traits aren't necessarily a separate concept from a type, and I don't really want to store every single possible trait in a giant array, since there's like some scoping. Like, enum traits will only exist if we are defining this to be an enum type specifically. So this is already the correct structure, as opposed to any. Though we could keep any in there. What is I128 for? For a 128-bit integer, which exists on some operating systems and actually exists in Rust too, surprisingly. If I go to standard library, no, actually it would be in types. Would it be in here? No. I could have sworn I had like an 128-bit type in here. Compiler value API. Size. Did they not put it in here? But there should be a possibility of I128. I can't type. And U128. Put that in there for now. No compiler errors. See? It's real. You say enums are integers. Why do you make them a different type? Because there's not really an easy way to... There's not really an easy way to define ranges of integers. So, if I was trying to describe a 64-bit integer, there's max value of 64-bit unsigned int. So the current way I'm storing enums is as a vector containing all of their possible values. So I would have to keep an array this long of all possible variants if I did actually treat them as an integer. Because you would have variant 1, you would have variant 2, you would have variant... I skipped 0, but you would have variant 0. All the way up till the max value, and all of those would be inside of this options variant with an array of all those different enum variants, and I could technically describe it that way. And then every time we do a comparison operation on that, you say, hey, this is less than 100. Suddenly, you would do a I guess like a remove if like iteration over this, where like for every single value that is over 100, we just remove it from that list of possible variants. And that's just like, okay, taking a step back from theory, we need this to be runnable within our lifespans. And also fit onto the RAM of, like, I mean, it'd be nice if this works on a laptop. Like, I run on a NASA gaming PC, but, like, it'd be nice if this runs on a laptop, because I know not all of my users are going to have NASA PCs. So, we do not store enums, we do not store integers as an enum, because I don't know how to store ranges of enums. Now, I could, like, well, no, because the way that I store enum labels is strings, so they're inherently unordered. And because of like the dynamic, so because the compiler runtime is dynamically typed, enum variants exist without an enum definition existing. So we don't have something like a table of all the names of an enum, for instance. If we had something like that, I could create like, here's the integer enum definition, and that's how we get like the labels for enum variants, and then we could store enum variants as an index. And that's basically what we're gonna do at runtime, but for compile time, enum variants exist before their definitions. So PC specs, system information. There you go. So we're running a Ryzen 9 7950X3D and an RTX 3090. Where is? It's somewhere in here. Maybe that's under components. Display device? Could be under ports. I don't know. Somewhere in there, there's the graphics card. Splitting the arrays up into different... It doesn't help. I need to define. Yeah. See, I would have to either create a special case for numbers, which is what I'm already doing, or I would have to have enum definitions ahead of time, which something that my runtime currently isn't equipped to handle. Yeah, it's not worth trying to make it handle that either. Okay, not getting distracted. The thing that I wanted to decide is how to handle recursion here. Right now, the current solution, which is bad, I don't like it, is that anytime you see lazy here, that's actually a function you call to get the rest of the value specification. Because otherwise, the value specification for value specification was infinitely recursive. The stack overflowed immediately. So I kind of gated it at the recursion, recursion points. Kind of made it function instead. But the better solution is to make it be possible to define recursive types. So we need to say, when evaluating this type definition, we should say this is an enum of type nested, and then the actual type value. Or this is a self, like a reference to self. Redo the entire enum again. Now, this is because we can have recursive type definitions. The types themselves can't be infinitely recursive, like that's just mathematically impossible. But the definitions can be recursive. Like a valid type is theoretically infinitely recursive. Like if we somehow broke the laws of reality to pass in a type that is infinitely recursive, that is technically valid. So we need to be able to specify that. I guess I just do need to find everywhere that I say spec and replace it with type, because now this is type. Just means we'll have to pass. When we're checking types, we'll have to keep track of what the root type is. That's not the end of the world at all. It is what I was trying to avoid, though, by making weird workarounds. Very weird workarounds. And then this type is what will pass into anything that requires a validator. So we no longer have a constraint system, we just have a type system that now is able to represent types that are larger, much larger. Here's the thing. There's always a thing. Here's the thing. Dang it, I forgot what I was gonna say mid-sentence. What is the thing? Here's the thing. Right. We want to be able to scoop functions by types. Actually, does that make sense? Or do we? Vsauce music. Oh, wait a second. I just realized. The label of a type, technically, is another thing that we have to take into account. So if we have two identical... If we're trying to do this, and... If we're trying to do what I'm talking about here, where you have one function that internally has a match statement that executes multiple different functions depending on the types passed to it, which would be a compile time thing. We don't have to worry about a runtime cost for that. It needs to be able to accurately match on the types passed into it. Now, let's say you have a vector 4 and a quaternion data type. The members of both of those structures are probably named exactly the same. Therefore, to a purely structural way of defining types, like purely through structures, through the structure of data, then you run into the issue of like the type not being labeled. Not the type not being labeled, but matching on the wrong structure of data when you wanted it to be something else. Now with enum variants, I already have labels for the variants. Alright, I think I'm gonna end the stream here since it's pretty late. It's like 1 a.m. But now I know this is what I need to do. Create a very good description for every single possible type. Make sure it's very easily discriminated. For the purposes of pattern matching and whatnot. And then that is our constraint to end all constraints. And yeah, I have a lot more clarity on where I'm going now. Yee. Alright, thank you for sticking around, and I will see you next time. Come on, hand. Here.